Hello everyone. My name is MD Shahidul Islam and I am a PhD student in the Department of Mathematics at UTC. Today, I will present my second homework for the parallel algorithm course, which involves a prime number generator using Pthreads. Generating large prime numbers can be computationally expensive. In this assignment, I demonstrate how to parallelize the search for prime numbers using multiple threads. Each thread independently generates a random number and check for primality until it is prime is found or maximum number of attempts is reached. Let me walk you through the code. I previously wrote this code and right now I will explain this code. So I define that the maximum number of tries is 10 and the maximum number of values, that means that the random upper bound for the random numbers, this is the upper bound for the random number. We just define and try to find out find prime, and this find prime we just define in another function, is it a prime or not. So firstly, I will go to the main function. In the main function, just I declared that there's a number of threads equal to 30. This is a by default. So if the user provides the number of threads, that means that they take that threads from the user number of threads. So after the number of getting the number of thread, how many thread do we have? So we just generate a number of thread IDs for based on this number of thread. Then we create a thread IDs for each thread. Then we join this thread together and we call the find prime for each thread. So in here, when we created the thread that time, so we just call that the find prime for each thread. So in that find prime, we just firstly we just started, or we just generate a random number, and we using a random function. And if this random number is prime, that means that if it is less than 1, that means that, or equal to 1, that means that this is not prime. If it is equal to 2 or equal to 3, that means that this is prime. Or if it is divisible by 2, that means that this is not also prime. Or if it divisible by any kind of number itself, that means that it is not also prime. So if it does not hold this kind of properties, that means that it is prime. So this method is called a brute force primality check. So when we call checking this random number using this prime function, that means that if that will be prime, that means that the found equal to 1, so they can show that this is a prime number. If it is not a prime number, then they can generate again the prime number till the max star is not matches. If the max star is matched, that means that they cannot find any prime number for this thread. So they print it and they execute this thing. So this is my code. So right now I will just show run my code. So I will just run my code by this command. So I using the wall function and O3 and pthread. This is my code name, file name, and this is the extension name. And for generating a random number, I use this extension. So when I run this, that time I ran already that means that, so I need to run the execution file. So when I run the execution file, if I provide 10, that means that it just taking 10 threads. So it just generated 10 threads, which number is prime. So in that 10 thread, you can see that for a thread 6, this is that random number that is a prime and no other number is prime. Okay, so if I have doing this thing for nothing, so if I do not write anything, that means that it takes by default 30. So it shows the 30 numbers. For in the 30 numbers, you can see them for the thread 8 is prime, thread 17 is prime, thread 12, 22 is a prime, and thread 29 is a prime. So if I say that things for a 100 thread, also they can show this is an for a 100 thread, and we can find out the thread numbers, prime number, or for each thread. Is it a prime? The random numbers, they can generate a random prime number or not a prime number by a brute force primality checking method. So that was in my code, and in my code, this is my code, and for the random number and the sample output. So thank you everyone for watching my videos.